Hello, welcome back. So, I'm going to show you all where we're at today. As you can see, the shader problem we were having in the last video has been completely resolved. And I did this by basically removing the shaders entirely. It occurred to me while debugging the problem, the only reason I was using shaders was to implement a bunch of old CRT effects that I have no intention of using for this game engine. So that all that added complication was just getting in the way, and in this case it was a bug that was just not worth fixing. So I cut it off. So, brief review of how the rendering engine now works. The shaders have been deleted from the display directory. I only have this index file. The context has changed from a WebGL to a canvas rendering context 2D. Pixel array is, you use it the same way, but it's a slightly different type to make it compatible with the 2D rendering context. And writing to the pixel array works exactly the same. After rendering, instead of pushing data out to the shaders, we just put all this image data out to the rendering context. It's actually a lot simpler. Creating the context is easier because we don't have to get all those locations out of the shader. One thing we do have to do though is, where was that thing? The resize event. When the window is resized and on the initial load, we do some calculations to make sure that the canvas is the correct size and centered on the screen. Which is basically what the vertex shader was doing previously. And it's actually kind of nice to have all this in the JavaScript because we're going to need to do the same math when we work to figure out how to implement mouse events. Because we need to know not just where the mouse is on the screen, but which virtual pixel is it covering. So, now that all that's out of the way, we can finish writing our draw line function. And for that, let me load up the algorithm we'll be using. Go to Wikipedia, a decent description of Bresenham's line algorithm, which we're going to reproduce here. And it's actually there's a lot of ways to draw an arbitrary line across the screen. But this one was developed because, well, it's fast. There's not a lot of multiplication going on. Reading through the whole thing is interesting. I'm not going to read it all to you. What we care most about is probably this. You convert that little algorithm into JavaScript. And let me make sure I'm reading this right. Oh yeah, because we have basically our equivalent of the plot function with setPixel. We should simply be able to convert this thing. So here's how you convert pseudocode into JavaScript. They name their variables a little bit differently. Change x1 to x2, y1 to y2, y0 to y1, x0 to x1. Just everything matches. And D is not constant. And Y is not constant, is it? No, it is not. And let's make the for loop look like a JavaScript for loop. See it, Code Whisperer is trying to shove its own ideas in there. Sometimes that's okay. It's not what I want to do right now, though. Plot is being replaced with set pixel. We know X, Y, and color now. Oh, this should actually wrap all three of these lines. Now, let's see, we got to make sure that x1 is less than x2 and y1 is less than y2. Let's calculate this up here. We only care about that when we're not drawing a pixel. We don't want to do any more math than is necessary. And pre-calculating those means we don't have to have that in our loop, which is probably just a good thing. Because I'm not sure if JavaScript is rerunning that function on each iteration of the loop. It probably is, because all of those values might change. We don't want that. Alright, so now we know that we're always subtracting the greater number from the lesser. And x is always moving in the positive direction. If x max was less than x min, then this loop would never break, because x min would never reach x max, or basically. Checking to see if there's anything else we need to change there, but you know, that might just be enough. Let's test it. First, let's see the state of the program right now. Once more. Looks like that. It's at a yellow line. And if all that works, it should, like, assuming we implemented that algorithm correctly, it should draw a line across the screen. A black line. Why is that line black? That line is black because I changed the implementation of our color object. You can see they all have the alpha value there now. Something I forgot to mention, because we're now using the 2D rendering context, we are now required to have all 4 color channels, RGBA, which I wrapped that up in a color object to try to make that a little easier to work with, but now we need to actually use the thing. This will just take a second to rewrite. because the alpha value wasn't set previously. It was set to undefined, which was probably causing it to be set to 0. Which should explain the black line. Alright, let's try that again. There you go, nice. Now, let's see if we can create a line that starts at the origin and then traces a circle. Just kind of spins around. That would be a nice way to finish off this demo. For that, we're going to need an angle that we increment each time we go through the loop. So the line is going to start at the center of the screen, which we do have get width and get height defined. And the radius, do I want to use that? It's not a bad suggestion. Let's keep it. I'm just pausing for a second to see if Code Whisperer gives me a reasonable suggestion, which it actually is. Let's see, and these are measured in radians. So we need to convert our angle. I want our angle to be in degrees. Let's see if he'll convert it for us. Sure, let's do that. It's basing off of the current time. I think that's delta time though. Oh, let's crack it open for a second. The function, so the callback function we're using, the render function, receives one parameter. Callbacks pass a single argument, timestamp indicating the end time of the previous frame's rendering. So it's basically it's the delta time. How much time has it been since the last frame? I think I am going to keep our angle variable. Oh, no, I know what I want to do. Got delta time and total time. And then we can do that. Then we can base the angle of our line on the total time through the app so far, rather than incrementing the angle directly. Center X, center Y, and then just X and Y for the endpoint of the line. We'll draw a line from the center to basically the outside of the circle. And radians needs to go into the sine and cosine. And let's see if that works. Kind of. That kind of works. It's kind of fast. Let's do that. We'll just keep adding zeros to the end there until time looks reasonable. That's still way too fast. That's better. Sort of. I'm not sure why it's not tracing the full circle. Also, it's getting faster. That's interesting. let's think for a second. So, the formula for angles or radians. An angle is basically radians equals degrees times pi over 180. So I think I'm just using the wrong formula. Which is why I keep saying you gotta keep your brain turned on when you're using Code Whisperer. I think I'm right. Oh, now it's not. Well, okay, now it's too slow. That's a good sign, actually. We'll send that back to 1,000, basically converting the milliseconds in total time back into seconds. Well, no, I really thought that was going to work. Let's go back to using a counter here. Now it should sweep through all 360 degrees. Well, that's just goofy. Let's try clamping this. I don't think that'll change anything, but it doesn't hurt. I'm sure there's a typo in here. I'm letting Code Whisperer rewrite that line for me, just for grins. But that didn't make any difference. Begs the question of if I set up this function correctly. X min, X max, Y min, Y max. You know, I don't think I did, because like if I swap the X value but not the Y value, with my min max swapping, that could actually lead to a different slope for my line. I might have just done this to myself. I'm switching this back to the original parameter values. Leave those the same, but our delta x and delta y that uses to walk across the line, we need to leave those like that, I think. Let's see what that does. Oh. Interesting. I still think that was the right thing to do, but it didn't fix the problem. You want to make sure you're starting at, well, no. You know what? X1 to X2, we're just going to leave that, and it's still not working, but I'm going to confuse myself swapping these variables around. So why is it drawing a straight line at the start of the loop? It's just going straight out horizontally before it begins tracing. Write that up to the log and see if we learn anything. Honestly, it's not telling me much. Because what it looks like it's drawing is that the y value stays the same for a big chunk of this. And also it looks like the numbers never really go negative. Not writing outside the array, so I know it's not that. So this might just have to be the cliffhanger we end on for this episode. We are getting the lines to draw correctly, but we cannot get the lines to animate correctly. Not sure why yet. I'll have an answer for you next time. Wish me luck.